Uh, Good morning, everyone. I, Shruti Tripathi, wholeheartedly welcome you all on this concluding day of 5-day national level FDP on earthquake safe design and construction practices. We all have learned a lot from all the technical sessions from honorable dignities and also enjoyed the non-tech session past 4 days. So let's continue this journey of learning from our very first session of today on earthquake and traditional housing system. It's my honor to introduce you all the eminent speaker of this session, Mr. Rajendra Desai, sir. Sir has completed his BTech in civil engineering from IIT Bombay in 1970. Later, he got his MS in structures from Rutgers University, USA. After working in the USA for 12 years, he returned to India in 1985 with his architect wife, Rupal, to focus on the software technologies for shelters, water, sanitation, and energy, which are more sustainable and viable in the Indian context. For next 8 years, he worked with different NGOs on these issues, getting exposed to the grassroots conditions in this field in the country. A damage assessment assignment for Government of India in the aftermath of 1993 Latur earthquake in central India took him into this field of disaster risk mitigation, which soon became his principal field of work. He, along with his wife, devoted much effort in the performance improvement of the buildings made with vernacular building system that predominantly depends upon the local materials and skills through the input of modern engineering and to some extent the modern materials. In the past 2.5 decades, he has worked on disaster risk reduction of building, especially houses, in many parts of the country, including Latur, Jabalpur, Kutch, Uttarakhand, Himachal Pradesh, Delhi, etc., as well as in Nepal. As a part of these efforts, he has been involved in the post disaster shelter rehabilitation programs, disaster risk reduction technologies, demonstration projects aimed at housing as well as public building, training of construction personnel, including engineers, masons, etc., as well as making of IEC materials such building technologies, manuals, brochures, etc., for agencies like UNDP India, UNDP Nepal, UNESCO, BMTPC, Gujarat State Disaster Management Authority, Bihar SDMA, and many more. His work, jointly with his wife, has brought him a number of honors, including the Hudko Harihum Ashram Award in 1995, first A.S. Arya Award of IIT Roorkee in 1998, Distinguished Alumnus Honor from IIT Mumbai in recognition of his work of the grassroots in 2010, Hudko Design Awards in 2013, 2014, 2015, and 2016, and Jamnalal Bajaj Award 2018 for Science and Technology in Rural Development. Along with these technicalities, Sir's passion also include love for mountains, trekking, traveling, and music. He has extensively traveled through the Americas from Arctic Circle all the way down to Terra del Fuego and Antarctica. Sir has also traveled in West Africa, including hitchhiking north-south across the Sahara. It's my honor to invite Honorable Joint Director, National Center for People's Action in Disaster Preparedness, Engineer Rajendra Desai, sir, for this session. Over to you, sir. Thank you.
Right. Yeah, thank you very much. It is indeed
Sir,
my
sir,
pleasure. Yeah,
sir.
sorry.
Yeah, sir. Before you start, I want to say one thing.
Certainly.
To all the participants, um, Rajendra Desai sir is not known as a single person. Always his wife Raj is always be there. So as far as if you look at the email ID also, it is the Raj. So that is the email ID, common email ID they have. And as and when we are conducting any program, uh, madam and sir both are coming together. So Rajendra Desai is the engineer and the madam is architect. So it's a wonderful combination also. And I think they have done extensive work as Shruti has said. And, sir, I think you have done a remarkable job as far as rural housing is concerned and traditional housing systems in India is concerned. Sir, please, it's over to you, sir.
All right. No, thank you very much, Sangvi Sahib, for this kind of flattering remarks. No, and it's really a pleasure to be on this platform and talking to so many professionals and I guess academicians. And especially since Latur earthquake, we got into this vernacular buildings. We didn't really know much about them. We knew about mud architecture and all those things, but it was really Latur intervention that really got us fascinated about what people can do without engineers and architects. And so that was 25, 26 years ago. And since then, we had opportunities to work in different areas. And I think this is what basically I want to share. And also I want to talk about the wrong impressions that we engineers carry about these buildings. And I'm sure my next presentation by Vivek Raval and Kiran Bhai also will talk about rural housing. So there may be some overlap here and there, but let's begin. So basically, I'm going to be talking, as you know, about earthquakes and traditional building systems. Now, what is traditional building systems? It's essentially, what's called vernacular architecture, vernacular buildings. And, these are the buildings built by people without architects and engineers using age-old proven building technologies. It is not just some mumbo jumbo, created by people, but there is a lot of logic and a lot of proven history. So basically, these vernacular buildings, they form an important part of the culture of an area as much as language, food, and dress. And they also give a local identity. Very, very important part, integral part of all this. So, sorry, why is this not moving? 1 minute. Wait a minute. Let me, I don't know. Let me just restart this thing here. Why it got stuck. Why I don't see this icon here? All right. Okay, sorry about that. Technologies. All right. Let's move forward. So, let's look at very quickly some vernacular buildings in different parts of the country. Earthquake or no earthquake. Uttarakhand, of course, typically has stone buildings. There are mountains, nothing but stones. And of course the forest. So there is timber, there is stone, and a little bit of earth. So it's predominantly stone. And we go to northeast, there's ample biomass, bamboo, timber, variety of reeds, and you get, Arunachal, of course, is rich with vernacular systems. Each tribe has its own system. And then you go further, kind of a little bit south from Arunachal into Meghalaya, and you have this timber and bamboo system. Each one has its own peculiarities and very much related to the local things. And of course, in Kutch, there's a lot of stone and there is a lot of earth. So you have architecture which is combined with stone and earth. And overwhelming majority of buildings fall in this category, vernacular buildings. And unlike, we engineers think that we are these sort of designers and builders, but that is really not true. And also, interestingly, in a lot of these areas, even the lifeline buildings have been made with this kind of technologies because they are endemic to that area. And a little bit about North Gujarat, where it is semi-arid. You have also earthen architecture, just straight mud or earth. And going back up in the Himalayas, in Spiti, and of course Ladakh and Lahore, and all these areas which are, in the rain shadow area, they get a lot of snow, but not much rain. And, they are all earthen buildings because there's a lot of earth. And then, going to Kashmir. Kashmir has different zones, like all the states. And Kashmir is parts, you are in the hills where there is a lot of rock and there is a lot of woods, trees. So your houses made of timber and stone or just stone. And then you come in the valley of Kashmir, Kashmir Ghati, what we call, and there is fantastic soil to make bricks. So you have brick masonry, fantastic brick masonry you have, you know. And also let's look at some international stuff, because a lot of us with a lot of money, we go to see, we go to England and we look at the British Tudor houses, which are basically timber laced brick masonry, just absolutely gorgeous looking buildings. And up in northern Italy, which is part of Alps, and you have stone once again. So you have random rubble masonry, just like we have in our mountains. And in southern Germany, which is also abutting Alps, there's a lot of timber. So you have timber buildings. And of course, in Switzerland, it's basically a lot of stone. And then look at this building. Look at this house, which has stone roof. It looks more like slate or flat stone. And this could be anywhere in Himachal or Uttarakhand. There was a time when we had a presentation in Uttarakhand, and I was showing them these houses, and they were saying which part of Uttarakhand they are from. So, but these are world famous architecture, and people spend so much of money to go and see that. And of course, we have another very interesting example of architecture from New Mexico state of Southwest United States. There's architecture of Pueblo Indians. These are the natives of America, of that region. And what you see here is the traditional American Indian settlement. It's a multi-story. You can see 3 levels, all of mud and timber. And this has become so popular in that region that expensive mud homes are made using that architecture. A lot of them may be mud houses, a lot of them may be make-believe mud houses. And believe it or not, we visited this area back in 1983. I mean, how many years ago? Almost nearly 40 years ago. And even then, we visited one house which was $1 million house made of mud, And very interestingly, you have this 4-star hotel in this town called Taos, which is a very popular tourist attraction. And you have this 4-star hotel, which is imitation Pueblo architecture. I mean, can you imagine things like that happening in this country? So it's a different world, and people appreciate these things there. Now, we need to look at some of the facts of vernacular buildings. Number one, as I mentioned, they're part of rich cultural heritage that provide unique identity to every region. Even a small state like Gujarat, it's a tiny state, and you have, oh, sorry, come on. Sorry, yeah. Small state like Gujarat has so many different traditional architecture. You go to Downs, which is hilly and a lot of biomass. You have one type, and you come in the in the coastal area of South Gujarat, you have something else, and then as you move up, it changes. And of course, in Saurashtra, it's different, and Kutch, it's different. So this is something very, very unique, and it's very rich. And interestingly, in Europe and Latin American countries, these traditions are still very much alive, and people take pride in them. You go to England, and even the smallest of the town will have buildings and houses which could be easily 200 to 300 years old, and people take pride in possessing them and living in them. And this is not in only non-urban areas, it's also in urban areas. And also, we need to understand that they produce long-lasting buildings that are often known to last for a century or longer. And this is very much unlike our modern technology buildings. Whether we like it or not, we have to accept this fact because we see this all around us. And these are most viable in rural and semi-urban areas, which are not densely populated. They're easy to build. These are very, very simple technologies. And they're made with local materials. I'll not say locally available, okay? Today, locally available, even cement and steel is locally available. So these are local endemic materials, okay, and local skills. And they're most economical in the respective areas. And as a result, they're accessible to local population. Even the poorest person would have access to these kind of buildings. and these are executed by local artisans, who know their area best. You don't have outsiders coming and doing things, and then it results into a lot of problems later on. And when we talk about earthquake, one must understand that more forgiving. You make mistakes and still you must survive. All right. Hmm? All right. There are a lot of myths, there are a lot of false understandings about this. With our civil engineering education, which starts and ends with cement and steel, there are biased mindsets. All right. I mean, I completed my IIT education 50 years ago, and that's what I learned: cement and steel. We were not even taught about bricks. All right, and I don't think things have changed even today. All right, and this ultimately creates our mindsets when we come out of our colleges. About the vernacular and traditional building system. What is it? Number one, we feel that they're outdated and they have no role in modern India. Just trash them. All right. Number two, they are not scientific, and hence they are not worth considering for use, and hence not worthy of research. Tell me how much research gets done in these IITs and NITs and all other big engineering colleges. How much research gets done? Really, very little, if any. All right. Unfortunately, that considered a sign of backwardness, poverty, and shame. All right. And we give it a derogatory name called Jhopri. Huh? All right, that's called hut or Jhopri. I mean, that means something that's bad, something you want to disown. All right, um, and they're called kacha. All right, and hence unreliable and safe. It's very, very interesting. That if it's kacha, then unreliable and safe. That's what our engineering mindset tells us. And so engineers are ignorant about the subject and hence have abandoned their systems in all their use. Now, what has also happened in last, I'll say maybe 26, 28, 30 odd years, poor performance in the recent disasters of these vernacular buildings has strengthened the mindset of the engineers and as a result, the people. Now, let's look at some very, very quickly performance in recent disasters. It was 1991 Uttarkashi earthquake, very quickly 93 Latur earthquake, and basically stone houses. This is what happened. I mean, these houses simply disintegrate. And in a very small area of 20 kilometer by 20 kilometer, just think of how big that area is, 400 square kilometers, something like 9,500 people had died. And few years later, 1999 Chamoli earthquake. Again, these are stone houses, and houses perform pretty badly in a small area. In between, I missed 1997 Jabalpur earthquake, which were essentially brick houses and mud houses. Very small earthquake of very low magnitude and still kind of intensive damage in several villages. All right. Uh, More recent 2001 Kutch earthquake, and once again the vernacular systems primarily of stone, and of course earth, and some places bricks, and these buildings did quite badly. And then 2005 the Kashmir earthquake, and again brick and stone houses, and this is the kind of thing happened. The Kashmir earthquake, of the epicenter was in Muzaffarabad, and as a result, the damage and the destruction and the deaths were in a far larger magnitude in the Pakistan side, but still a lot of damage. And this does not mean that vernacular buildings, which are what we call people-made building, have to be so vulnerable and weak. Now let's understand a little bit about these buildings, the building systems. First and foremost, these systems can bring safety against disasters. Unlike what we engineers think, if they're built as per the age-old traditions that proven performance. All right. What we have been seeing is far from that. I mean, I've been involved in the damage assessments in Latur earthquake, and something like 5, 6 disasters. We have done damage assessment quite detailed at point zero. And the first thing that comes out is that there is dilution in technology. There are missing elements, typically bands and whatever. I mean, there is acute dilution, which has happened in last 30, 40 years for a variety of reasons. And this makes these buildings vulnerable. Of course, there is deterioration quality also due to degradation of artisans. Gone are the times when mason's son was mason and carpenter's son was carpenter. The last 50 years after India became independence, things have changed dramatically. And for a variety of reasons, this tradition has broken down. And as a result, new people have entered, resulting into degradation of their skills and knowledge. And what they build, lack of maintenance. Our society, we are not known to be great at maintenance. We all know it. We can see these things all around. And so older buildings, obviously, when we talk of vernacular buildings, you have buildings which are 50, 60, 100 years old. And obviously the age, with that age you pay price in the disasters. As population is increasing, you are building in wrong sites, and a lot of these are vulnerable sites. Obviously, the buildings suffer and people lose their lives. So let us see some great examples of disaster-resistant vernacular buildings in disaster-prone regions. All right, let's start with Himachal Pradesh, which is obviously in the northern Himalayan belt, which is zone 4 and 5 of seismic zonation. And what we have there, the traditional buildings are the timber lace random rubble masonry, which supports the timber roof and the timber floors and the slate roof. Now here is a classic example. This is probably 50 or 60-year-old house, which has light timber living quarter at the top. And this is a fairly new building on the right, and you see multiple bands. So you have course of the random rubble, and then comes a timber band, and again random rubble and timber band. And you see the difference, one in the upper right hand corner and the lower left hand corner. The lower left hand corner doesn't look that new, or maybe it's a poor man's structure, but still you find multiple bands in that. And one more example, and a lot of these are roadside, or a lot of them are inside the forest. And needless to say, you find multiple bands. Coming to Uttarakhand, once again you have timber lace masonry with random rubble, and you have this heavy stone roof. This is not slate; it's called patal. And these units are like about 2 inches thick. They weigh a lot, and of course they're fantastically insulating. And you have intermediate levels of timber floor. So once again, these are light timber living quarters. These houses also must be 100, 200 years old, but provide excellent examples. Here's one more example with multiple timber bands, and here is another example where you have vertical elements of timber. So talk of engineering, all right, and these are so well connected. Okay, you look at this. Let me see, get my cursor. Here is the through and through timber element, which anchors this vertical reinforcement. Here is on the left hand picture again. You see this timber elements which are through and through, and so they provide fantastic bonding with the random rubble, and then this brings ductility. Modern engineers, we talk of ductility, but it was already there in the traditional system. And here is probably, I think, India is probably the best example of earthquake resistant building, what's called the Koti Banal architecture of Uttarakhand. This is a 6-story building, believe it or not. Of course, stories are not that high. Each story may be 6 feet high. And I've had the good fortune of going up all the way to the top story. All right, this is at least 200 years old, and which means it has seen so many earthquakes. And you see this timber element in the lower right-hand picture. You can see my, this thing here, and this is like one whole tree. Of course, this is not viable today. But what we need to do is understand, to appreciate and respect this architecture. All right. Now, look at Kashmir. The Valley of Kashmir also has some fantastic example. On the left, this picture you see thick brick masonry piers. Like after every window you have a masonry pier which is about 2 foot thick, and it's all in mud mortar. Inside you have walls which are solid, which are essentially sheer walls, and then in between, in the at the floor level, you have this double layer of timber providing fantastic timber diaphragm. All right, this is called a tak system. Tak actually means window in the Kashmiri language, and by modern principles of of earthquake engineering, we will say, oh, it's too many openings and this building is vulnerable. But hell no. I mean, this building could be easily 100 years old, all right? And mud mortar, kacha building, what we call. All right. Let's look at the thing on the right. This is, I would say, probably a legacy of the British, the timber laced brick masonry. But now this has also become very much native. And in the valley of Kashmir, whether it is Srinagar or Anantnag or Baramulla, all these big towns, you see multi-story buildings with this. All right. And I mean, there's a clear-cut stress path, in the well-designed these kind of Dhaji Diwari's building system. And interestingly, you also find combinations that you have a 6-story building of this traditional thing, and where the lower stories will be made with tak, which are heavy, and then as you go up, you have Dhaji Diwari, and then at the top you may have a timber floor, all right, timber story. And here is a fantastic building. Again, I had a good fortune to get into this house. 80-year-old. Of course, this picture was shot 10 years back, so it's 90 years old now. A type structure, and typically, Kashmiris have parties in their houses. So the top story is without columns in the middle, without walls in the middle. Imagine. I mean, this is vulnerable by any of our modern engineering systems, and still they have survived multiple earthquakes. All right, let's move. Let's look at the northeast, Arunachal, and what you have is either tactile timber houses or bamboo frame houses. This particular thing on the left side, you see this from the Bomdila area. This is in fact in Bomdila town, and this is timber. You have this solid timber column and your timber beams, and all these are this wooden 2-inch thick timber panels, all tongue and groove system, just beautiful. No earthquake can destroy this. So this again could be easily 100, 150 years old. And then of course you also have bamboo and timber, kind of a bit lighter structure, which are very, very ductile. And you have bracings in every way you can think of, all right? And of course, see, these pictures of mine were shot back in 1993. We were doing a study in in Arunachal and Mizoram. So those days, they have this. They had thatch roofs, which would last for many years. And look at the lower left-hand picture. These are big houses, and Arunachalis, like 100 individuals would be dancing inside, so that floor can take dynamic forces of people dancing. And that's why you see these bracings in every conceivable direction. And see, here's one more example. So you have these things, I mean, what better engineering you can think of. And after that study, we had made these drawings, and look at this marvel of traditional engineering. You have bracings in the walls, in gable walls, long walls. You have bracings in the in-plane bracings under the roofs, all right? And you have bracings under the floor. Okay, there are a lot of locations which have strong winds. They may be along a ridge, so they're very strong against wind loads, and of course, earthquakes always there. And what was interesting, this is back in 93, there was absolutely nothing non-local, nothing, all right? You found bamboo used in variety of ways, all right? I mean, I could make just a presentation, 1-hour presentation only on these houses, okay? But the thing is that there was nothing. Of course, recently, 10 years back when I visited, you have now RCC posts below, and you have CGI sheet, for their, of course, own inherent advantages. and of course complications. All right. Looking at some Meghalaya and Mizoram, once again, northeast, and you have ductile timber or bamboo frame, and you have these panels which are made of bamboo mat or the other thing called ikra, which are flexible, and see, in recent times, of course, new things have started to come in, but again, you find most of them 2 stories high. And now as you see in the lower picture, in the lightened picture, you see this RCC posts have come in, and in the upper right-hand picture, you see this concrete blocks, probably masonry. So, and of course, the tin roof. Good old days, tin roof was not there. They're thatched. So, all right. Okay. Yeah. Now looking at some photographs of Meghalaya in that same area, and you have this very, very elegant heritage buildings. This is a 4-star or 5-star hotel in Shillong. We had good fortune to spend a couple of nights in this building. And here's a cathedral from Shillong. Both are what you call the Assam style building system, very much earthquake resistant. And you can see, the load path for the lateral loads. So, these are the traditional buildings, and these are all modern facilities. See, we in India, we have this mindset, that traditional buildings cannot have modern facilities, which is the most screwed up mindset. All right. I mean, you go to Europe and you find a 200-year-old house, and inside they have all modern facilities. So you don't have to demolish this fantastic, buildings to have the advantages of modern facilities. All right. All right. Let's look at some common people's houses. These are in Mizoram. This is actually a farmhouse, all right, away from the town. This is right along the road next to the fields. Now, this is like an 8 foot by 10 foot house, but it's most amazing. I mean, again, I can make a presentation on this house. The inside was amazingly compact and had all the facilities that an individual would need. But look at the bracing systems in both the directions, all right? And here's another house. It has modern materials. The panels are, I think, more like bison panels, and you can see CGI sheets. The bottom skirting you can call. So it's kind of safe against kicks and abuse, and of course CGI roof. Look at the bracings and the base, and this had actually a cable going around the house, and which was anchored by the roadside. So people have understanding, okay, that what kind of forces can come on these houses. Here is another very large structure. This may be a chicken hen where they rear the chicken for selling. But look at the bracing system there. And interestingly, I mean, look at the timber joints. Just using modern GI wire, they have strengthened the timber joints. I mean, these are very, very simple way to strengthen the joinery and to make the structure stronger and more earthquake resistant. Now let's look at some Sikkim houses. Again, a mixture of traditional and modern. You see the RC posts in this house at the bottom, but otherwise everything at the top except for the CGI is the traditional. And this is again Assam style. What's called this ikra. Ikra is a cane, and ikra or bamboo mats are infill, and this is plastered with. It used to be plastered with mud mixed with lime, and now of course also cement plaster is done. And here is a little more modern northeast house, with the panels again within the timber frame, but I think these are maybe cement sheet panels. So obviously modern things come and things are going to change. So it's a mix of cement and traditional system. All right. So new materials come, and of course they may have their advantage, they may have their disadvantages. All right. But what is interesting is this, that in 2000 East Nepal earthquake, or what we probably call as a Sikkim earthquake, there was very little destruction in this traditional building, and as a result, the death count something like 80 people. All right. Now, interestingly, what happened to the modern buildings? All right, sorry, again, still, this is look at the traditional system, the damage. Now, the here was the dislodging of ICRA panel. Okay, there may be deterioration of the infill, or there may be, some bit of shaking, and the panel came out from the groove, the tongue and groove setup. Um, Here in this building, you see in the house the infill random rubble wall, which provides an enclosure maybe for the animals at the bottom, has collapsed. Here is an interesting house with, the modern sort of the combination of the traditional system at the top and the modern RC stilt system at the bottom. And needless to say, see, the interfaces of the modern and the traditional are always complicated. And what you see here is, is the problem at the interface. The timber and the RCC, poor joinery has gone. And also you see an RC column has under distress because, this is all jugaad RCC construction. So needless to say, even that's going to suffer. But see, basically a lot of damage was non-structural, and even the structural damage was also of low order. Hence, it did not result into collapse of traditional buildings. Now let's see what happened to the. Oh, sorry, still, yeah. Also, there are a lot of monasteries, and monasteries are typically masonry structures. There may be some timber elements. So, needless to say, corner cracks developed, and maybe because of these big openings, you see the diagonal cracks that develop. Some places, of course, the damage was more, but see, these walls are pretty thick, and as a result, there are hardly any monastery had collapsed. And also, interestingly, here you see at the bottom, they had this retaining wall, and which has collapsed. These things happen all the time, retaining walls collapsing in earthquake. And here is damage due to stone fall. No fault of the building, maybe wrong siting. All right. So almost all the damage was restorable. Okay. What was really needed in this is to develop details. All right. To develop better interface of traditional versus in modern. See, this is where the engineer's role is there. All right. Now, okay, finally, I'm at the modern buildings, modern RCC buildings. What happened? Here is one example. This was quite close to the epicenter in a small hamlet of Chongtang. It had some 50 or 80 houses, and good majority was RCC. All right. So one of the things was happened was the collapse of the infill walls. Uh, Here is a school building, and it had a soft story. I guess it's a hall, right? So that collapsed. Very common, right, for stilted buildings. And here is a building of the Indo-Tibet Border Police, ITBB. This is an engineered building. The above two are definitely non-engineered buildings, but this one is an engineered building. All right, and look at the distress. And I'm sure they have demolished these buildings. All right. So, and the whole issue is, which are pakka and which are kacha. We are so strong on this pakka and kacha feeling. We feel that pakka is permanent, kacha is not permanent, pakka is safe, and kacha is not safe. But what would you ultimately deduct based on these buildings? And mind you, one thing, all right. See, these buildings, like I said, the bottom two buildings are government buildings, and the government has a lot of money. All right. So they can demolish them, they can bring a team to repair them and whatever. But what happens to the upper two buildings? Will this building owner have money even to demolish the building? All right. So this was a major dilemma here. The government had given 5 lakhs to each building owner, and they said, all right, do what you want to do. So this is, when we get into this modern building systems, which are complicated, we are getting into systems which are difficult to sustain. All right, I'll come to that a little later. Now let's, I want to a little bit talk about this pakka versus kacha phenomenon. Because when we talk of the traditional buildings, we can't get away from this. All right. So it is important to understand why this mindset of Pakka versus Kacha is evolved. And this is primarily endemic to Indian subcontinent. All right. I mean, you go to other areas, you go to Turkey, you go to Central Asia, you go to China. I don't think anyone talks of Kacha and Pakka. I mean, see, like I mean, I showed that those houses in the US, $1 million houses back in 1983. So the Ronald Reagan was the president of the United States. He had a mud house in Northern California. All right. So the Pakka versus Kacha is very much Indian. Okay. And it's also important to understand how this whole phenomena is affecting housing in our country. Now, what is happening today? The modern is replacing vernacular. All right. Here is an example of a vernacular building. This could be anywhere in the country. All right. I mean, typically you have clay roofing tiles on timber or bamboo, and you have masonry or mud walls. And against that, what is happening? You have this on the right side. This is a brick masonry infill with cement mortar and RC frame, a single story RC frame. This is a PMAY house. Okay. This is the government flagship project, very well meaning, so that people have long lasting houses. All right. And unfortunately, today, more than 90% houses which are being built under PMAY are of the RC frame type. Right. So I feel that PMAY is a death knell for the vernacular architecture. And then obviously, for people, this is one time opportunity in their life. This is something they've wanted, they've been brainwashed, right? So obviously they will go for this, but they don't know what they're getting into. So let's look at that now. And here's the example of the same architecture in that area. Just beautiful. I mean, there's so much of variety and so much to do with the local context. All right. So let's look at this replacing. What is it doing? It's basically the village wealth, whatever that little there is flowing to the cities. All right. I mean, this is the Gandhian thought, whether we agree with that or not, but this is the ground reality. The cement comes from the cities, the steel comes from the cities, and that's why these things are going. So the village wealth is getting drained and the villages become poor. Number two, money spent on these houses generates very few local jobs. All right. Because typically, maybe 80% of the money invested is in material. All right. So, what kind of local jobs? Ultimately, livelihood is the most fundamental thing for everyone, urban or rural. So, creation of jobs and buildings are the biggest creator of jobs. Now, one more thing that's happening is the villages are becoming dependent on the materials coming from far. This means that some extraneous reasons increase the cost of these materials, and people cannot afford these things anymore. Next point, villages are losing independence to take care of their most basic need. All right. Something, roti, kapda, makan. You want to be self dependent. And the self help possibilities are disappearing. Or even today in the villages, a lot of things people do themselves. They make their own bricks in many areas. In Arunachal, when they make these bamboo houses, the whole village gets together. All right. And they build the house in 4 or 5 days. We are adopting technologies that are not in people's control. And what do I mean by people's control? We all know about the problems we have with waterproofing. We have these RCC roofs leaking like crazy, and we can't do anything about that. Years ago we were in the south, in a village in South Gujarat for 3 years, and we lived in this pakka house. All right, and we had an office which had a Mangalore tile roof. Our house had RCC roof, and in monsoon, our house leaked everywhere. We had to decide which was the driest place where we could put all our valuable papers and other things. And I had a computer back 30 years back, 40 years back, Apple computer that time, first of the Apples. And in the office where there were Mangalore tile roof, wherever it started to leak, all you had to do was just adjust the tile a little bit, to put a bit of packing, and voila, the water stops coming. That is technology in people's control. All right. And of course, getting in a house that is culturally inappropriate, climatically inappropriate. All right. I mean, recently we've been involved in a major intervention in Nepal. Okay. Or needless to say, same thing is happening there. All right. Because so wherever the cement and steel can go, wherever the bricks can go, you are seeing bricks instead of the local stones. All right. You are seeing RCC slab. But very interestingly, once people start living in them, they're complaining the houses are hot. What do you do now? All right. So I mean, in Uttarakhand, when we did work there, people were saying that our children are falling more sick in so-called pakka houses, because they are cold in winter, they are damp in summer. So unlike your traditional houses, which are very well insulated, which are very, very waterproof, all right. And of course, we are losing identity and culture. Like in America, I mean, you bloody go from New York to Los Angeles, it's already the same thing. All right. So your cultural identity is just important. All right. Now, some more things. People switching over to modern building technology and materials because, all right, for Indian engineers, the ignorance about vernacular system prevents them from using it. I mentioned about this earlier. All right. Whether it is private project or public project. I mean, I remember going to Arunachal. We were at a 13,000-foot pass. There was nothing around, and far away I see a brick building, where there is stone everywhere. And I wondered. I asked somebody local, "What is that building?" And I was told that, "Oh, that's a government building." So you are 200 kilometers from the plains where the bricks are made. All right, and you bring those bricks and you make the government building with that. So this is what is happening. So establishment has switched over to modern building systems, even in the disaster, even the distant remote locations. All right, so you are setting an example for people to follow. All right, hey, this is the way to go. This is modern. Aggressive advertising by material manufacturers is shaping people's aspiration, obviously. All right. I mean, you see, Amitabh Bachchan selling whatever, you know, uh, whatever cement or steel or whatever. Obviously, people see these houses on TV, they see them hoarding, and obviously people will aspire for them. And especially when the traditional houses are called jhopdi. All right. The problem is that when a cement company is advertising the cement, it doesn't caution people about the problems in using cement. All right. The fundamental rules of cement. Okay. So all this is at the risk of misguiding them. And of course, there is peer pressure. We have seen poor people building a so-called pakka house. They borrow money and they get into debt. All right. And of course, today with all these new laws which are coming, which are a lot of them are anti-law, anti-people laws, the access to the local materials has been greatly constrained. All right. And this is again a hardship to people, which is forcing them to change over. Up in Uttarakhand, uh, people have this patal or stone roofs which are supported on timber, and after maybe 25, 30 years, the timber starts to sag under the heavy load, and people know that they have to replace that timber, and if they don't replace it quickly, the roof is going to collapse. We have seen houses with collapsed roof, the rest is intact. So what people are doing now, people who have money, they remove their traditional roof, they remove the patal from the roof. Patal is laid in the front yard for flooring, and they make RCC roof, all right, whether they like it or not, because they don't want the roof to collapse. All right. Okay. Some more things. there is total neglect of vernacular systems by engineering fraternity. All right. No advancement in vernacular construction to tackle age-old irritants and new constraints. Sure, every building system has irritants, just like the modern systems. All right. And these irritants have to be tackled. So if there is a leakage problem, if there's a tree sagging problem, then we have to do something about it. Okay. If we don't, then people are sort of forced to abandon that. The mental blocks prevailing commonly with the buildings of traditional technology cannot have modern conveniences. I mentioned that earlier. Okay. So somebody who wants a modern bathroom will say that no, I cannot have a random rubble masonry house. I have to have a brick house. All right. But nothing could be farther from being wrong. Irritants and limitations of the modern construction systems are being accepted and underplayed. Isn't that true? Like I said, in our South Gujarat house that we had rented, bloody thing was leaking everywhere. And people say, well, in rain, then they obviously leak. I mean, what happens to our roads, Pakka roads? Because they are badly built, we have potholes. And then people say, oh, the monsoon was so strong, so there are potholes. We accept these things. We don't say that, hey, these things have problems. All right. Vulnerability resulting from modern system is accepted and overlooked. What is the vulnerability? If reinforced concrete, we all know, we engineers know, that if it's not done as per the IS code, all right, your coarse aggregates do not have the right gradation. If the sand doesn't have the right gradation, if the proportions are not right, if the water cement ratio is not right, what happens? Your slabs are not going to be waterproof. Your beams also will allow percolation. What happens then? Of course, your roofs leak, but more than that, the leakage is, of course, maybe temporary. All right, maybe only when it rains, but your reinforcement corrodes, and what happens? We all know what happens. All right, but we don't think of it because this is the only solution we know. So the whole question is the so-called Pakka construction system really safe and long-lasting? All right. For an engineer based on our education, a structure is either safe or unsafe, right? We all do this thing, WL square by 8 divided by section modulus gives the stress, and the stress is less than allowable stress, then it's safe. If it's more, it's unsafe. Hey, redesign it. So which means everything is either black or white, nothing in between. But we all know that the reality is different. As they say in English, things are in thousand shades of gray. All right. Our buildings are neither absolutely safe or neither absolutely unsafe. They range everything in between. All right. The degree of safety varies from building to building depending on how it is built, who builds it. Since the building codes and rules of right constructions are violated routinely, what is done is most subjective. All right. I mean, one can have, in seconds. I mean, the seismic zone 4 and 5, we are supposed to use 1:4 mortar for brick masonry. But what the hell? I mean, one can use 1:8, 1:10, 1:12, isn't it? I mean, that's a reality that we see. So subjectivity. One can put any steel anywhere. We see jugards everywhere. All right. So the limitations of modern technology in Indian context, wrong practice means safety and durability is compromised. Modern RC-based systems comparatively are more complicated and less forgiving. I mean, we all know that one joint failing in an RC frame system can trigger failures of the next joints and next joint, and it can mean collapse of the whole structure. Vernacular systems that way are easier to build and more forgiving. Sure, I mean, if in a random rubble masonry, if there is no interlocking of the wires, if there are no through stones, the wall is going to come down. But some mistakes here and there, it's not going to come down. We all know that. All right. So Pakka does not guarantee safety and permanence. We need to accept this. Vernacular is a greater likelihood to bring safety and longevity because they are easier to do. All right. Anyway, but things are not all that bad, I'll say, because I'm used to looking at the silver lining to the dark clouds. Still, a significant percentage of population has been continuing to use traditional systems, even for new buildings, for a variety of reasons. All right. Significant work has been done for improving traditional building systems in different parts of the country. I'll say, especially since mid 80s, a lot of work has been done. We have been involved, many other people have been involved. I think our next speakers have been involved for a few decades. A lot of people have been involved in different parts of the country. You know, so work has been done in Kashmir and in Uttarakhand and in Bihar and Karnataka and Kutch and everywhere, Maharashtra. All right. So training programs have been conducted for training. Today a big program is going on in Bihar to train the masons. All right. So projects are being undertaken, have been undertaken to demonstrate and the technologies. And typically, post-disaster situation brings in a lot of money. All right, which is oftentimes not there in normal times. So these provide opportunities for such work. They provide opportunities for training. I mean, back after 2001 Kutch earthquake, in 3 years, our group trained about 8,000 masons. All right. So obviously, because there's a lot of money, there is a felt urgency at that point. So let us look at some examples of what kind of improvement is being done. First, I'll start, of course, with Latu because we were there. We were there for about 6 years, starting with the end of '93. We left Latur in 2000, but intensive work on technology got done in '94 to '98. Now, of course, we were absolute strong promoters of local systems, and hence, I mean, some of these houses came up at demonstration, and also we were able to convince some of the donors to take up programs. Now, very interestingly, you will see the right-hand picture. There never were brick houses, and there in the post-earthquake, people were so scared. So finally, they agreed. In this one particular village, or rather, 2 or 3 villages where we work, they agreed that okay, up to sill level, we will have stone, random rubble, but above that we'll have bricks. Their feeling was that, well, if the stone falls on the head, then it can kill them, but brick cannot. So we had to sort of compromise. So variety of things happened, and the left-hand picture is very much part of the traditional landscape, rural landscape, very much merging into it. All right. Also, the poorer people there, were building the mud block or adobe houses. And with our intervention, we also demonstrated to them that bamboo can be used as reinforcement of as a band at different levels. So these kind of things are done. All right. Some more examples in Latur also. I mean, although something like uh, 30,000 houses had collapsed, I mean there must be at least a few lakh houses in that whole region, the whole Marathawada and adjacent Karnataka, adjacent Andhra, where these kind of houses of random rubble masonry with heavy, mud timber roof are there. And they're all of the same system and very, very vulnerable. So we're also taken of retrofitting, of improving the traditional building system so that it becomes safer. See, one major thing we have seen was that in the post-disaster, people lose confidence in their system. And need obviously, because they will see, oh, that somewhere something what is called Pakka has survived. And I mean, in Killari, in '93 October earthquake, only one house was RCC house, and it survived. All right, because this was only a 6.4 magnitude earthquake, whereas you had these thousands of houses which are extremely vulnerable, and they were just waiting to collapse. Okay, because this was not a seismic zone, mind you. So obviously, when they see thousands of houses collapse and one RCC house standing, they all want that kind of house, and people are going to quickly run to those houses. So retrofitting is one way to rebuild their confidence, one way to prevent the demolition of these houses these wonderful houses that people are living in. All right. So simple measures were done, and we managed to work with 150 households and retrofit them using their money. All right. And this was basically done under with Professor Arya's guidance. All right. Later on in 2009 and 10 in Bihar, this kind of a multiple of NGOs, I think they will be probably talking about this in the next presentation. But they did wonderful work on bamboo houses. Okay. Now, in that particular region of Bihar, bamboo is the most traditional and common building system along with bricks, and each village has a bamboo crop, which you can have fantastic bamboo right there. Now the requirements of Bihar is that it is flood prone area, it also has high wind problems, and of course seismic zone 4. All right, so all three hazards are there. So the requirement number one was that there is water protection, that the house must not fall apart under flood. Whole bamboo, improved bamboo system had excellent cement plaster which adhered well to the bamboo walls. Number two, it was also important that when the area remains flooded for more than a month, people are able to survive above the flood mark. So the basic, the non-negotiable requirement was there should be a platform for safety where people can live at the height of 10 feet. All right, so that's third. Second, the third was the improvement in joinery. The traditional joinery had problems, so remarkable work was done, to improve the joinery, and several hundred artisans were trained in this. And of course, as we know, bamboo has a preservation problem. Bamboo will rot very quickly. And so, very interestingly, the preservation system was brought in, and special local professionals were involved to do treatment of local bamboo. All right. So, this is a complete system. See, in different countries, especially in the Southeast countries like Thailand, Taiwan, and of course in Latin America, amazing work is getting done. And some absolutely fantastic bamboo structures are getting built. Okay. But along with that, preservation is an integral part of it. Without preservation, you can't be talking about these technologies because they don't last long. So why would anyone not want to build a bamboo house for all these disasters? All right. In Kashmir, after 2005 earthquake, we had opportunity to make number of interventions starting with 2005, 2006, 2007, 2008. So one of the things we did, we spent nearly 3 months near the LOC, and what we worked on was the improved random rubble masonry in mud mortar house. So multiple bands were brought in. Now, traditionally, they used to have wooden bands in many houses. We had to bring in RCC bands because wood was not that easily available. All right. Uh, Better anchoring of the floor and the roof with the wall, integral part of earthquake resistant construction. We are known to build roofs just simply placed on top of the walls. So obviously, the buildings fall apart. All right. One of the things we did in these houses, they had this Daji Diwari. Most people know about Daji Diwari in Srinagar, which are timber laced brick masonry walls. But there are also timber laced stone masonry walls, which is about 6 inches thick. And these are also fantastic walls, all right. And typically, these are used interior divider, not what you call partition walls. Okay, these are shear walls. These are load bearing walls. All right. So we studied the failures, and what was needed, number one, was better joinery. All right. Also, timber to timber joinery. Next thing was required was joinery between the dhaji wall and the exterior masonry walls. Because otherwise your masonry walls are going to be weak, being very long. We also introduced a band that will go on top of these Daji Diwari so that that band gets integrated with the band on the exterior walls. And so all in all, we made major improvements in the Daji Diwari. I think this is common sense engineering going into it. All right. And you need to be sitting there. Okay. So I and Rupal and our team of, we are 5 of us. We spent 3 months near the LOC. We trained intensive training of 30 artisans in these buildings, and these fellows then later on built more than 300 houses for a major international foundation there. And this is a permanent thing which was left there with people. All right, the artisans are still there; they still communicate with us. All right, coming to Gujarat earthquake in 2001. So large number of NGOs worked, and of course, a few of them were technically competent. We were part of that system, and we worked very closely with Gujarat State Disaster Management Authority. So, like I say, we during those 4 years, we trained over, something like 8,000 masons. And in this one particular program with Gujarat State Disaster Management Authority, which was focused at some close to 500 villages, uh, about 6,500 masons were trained. So here is a multi-hazard resistant masonry house, which was built as per the official guidelines. It had multiple bands, needless to say, and it had simple fixtures to anchor the roof. Simple things were brought in. I mean, nothing hi-fi, common sense engineering, simple anchor bolt at the top of the gable wall so that ridge beam can be anchored. And of course, in the roof, simple diaphragm was introduced using GI wires. And as you see, you can see gable band and variety of things, but simple things were there. All right. Also, I mean, how would people know that this technology works just because I go and tell them? I mean, Latour was an interesting experience with us. Latour being so accessible, just like Kutch, there were so many technological groups working there, and each one had an idea to sell. All right, I mean, sell is a bad word, but basically these are all well-meaning. They want local people. But the whole question is which is right, which is better. Why would someone trust what I'm saying? Okay, so one of the things we did was shock table test. Now again, this is something we learned from Professor Arya, and he himself also had to perform a shock table test to demonstrate how effective his retrofitting scheme for random roll buildings was. All right, nobody in the government system, there was something like 550 government engineers from chief engineer down to the junior engineer in the field who did not believe in what he was saying. So he had to ultimately demonstrate it. So he got a simple shock table like this built, and he had tractor giving impact from both the ends, and it was a fantastic demonstration. So we took it up from him. We took his design, and in the engineering college in Latour, we built a platform, and we carried out 4 tests. So one of the tests had retrofitting in it, showing that retrofitting works. Secondly, we also demonstrated, about against like what people are doing and what needs to be done. So what you see in the upper left-hand picture, the right-hand model is a brick masonry building with cement plaster on it. The way it is done by people, in cement mortar. But typically people cure it for 3 days. All right. So that's what we did. We replicated what people did. And on the left side is a random rubble masonry building in mud mortar and with a RCC band at the top. And I think there are these small corner strengthening elements. And of course, the roof anchored to the wall. All right. So what you see is on the right side. What happened to the random rubble? It survived in mud mortar, whereas the house in cement mortar, with the way people build, it collapsed. The message is that what you guys are doing is wrong. If you want to use cement mortar, you better cure it and you better put band in it. All right. This was our retrofitting test. All right. What we had done, we had a load bearing with a heavy roof, and it survived 13 impacts from the tractor. All right. So I mean, we could very clearly see, how the walls delaminated and how they went out of plumb and how the whole thing ultimately came crashing down. All right. So these are, major confidence building exercises, not only for engineers like us, but even, and of course, for the people and for the artisans. All right. So, I mean, the message is that desired safety can be achieved through right techniques. Now, let's look at the hills. one of the problems in constructing in the hills, to construct the disaster resistant houses today. All right, if you're going to use RCC bands, even forget about RCC frame. Look at the left hand picture, see what happens. The house near the road is all right, but rarely in the hills you have a site which is on the road. Something even that is fronting the road, maybe 50 feet up or 50 feet down from the road. So practically everything has to be carried. And we had a site, this is somewhat, this is back in 2015. We were building a school building, and just for the bands, we had to take rods. Sorry. And just see what you see on the left hand picture. The bars had to be bent and bent and bent until they're about 5 feet long, which means that you go to the site and you have to straighten them out. The cement was brought in from Dehradun. Finally, when it reached the site, what we saw, the number of bags, the cement had hardened. We don't know what happened. Just in a period of 3 days, this happened. All right. And there are villages which are like several days inside. So let's just think that, what kind of complications you get into. On the right hand side, you see the sand being brought from the riverbed to the site. And of course, in the middle, you see the stones being brought from far away. I mean, this is like in a ravine, the stones are there, brought to the site and used. In the bottom, this is from Nepal, CGI sheets are being carried. Now, fortunately, here, of course, they had this earthen road. But imagine walking around, along a narrow trail which is barely 2 feet wide. The sheets will bang everywhere. All right. So these materials create major logistical hurdles, especially the materials which are brought from far. So here in Nepal, what we did, we evolved a technology back in 2015 called the containment reinforcement. This is a concept which was evolved by Professor Jagdish at Indian Institute of Science back in 2013-14 after Latur earthquake. In our shock test also, one of the shock tests we did was with mud blocks. When we did the first test, he conducted it with containment reinforcement. All right. And then, of course, that concept has come a long ways. And in 2015, we evolved with him, with his guidance, this system. And then this was submitted to the Nepal government. It was approved. All right. So this system basically has, as you see in the left-hand picture, the weld mesh bands. It's all done in mud mortar. The weld mesh straps are laid in the wall, and mud mortar is placed on it, and then the random rubble or brick can be placed on it, and you have wires, 4 mm GI wires on both faces of the walls, and you have this GI wire placed during the construction across what we call the cross links to anchor these vertical wires. So here in the left-hand picture, you can see these wires. You see a wire here, you see a wire here. So these are wires at about 3 feet gap vertically, and they're anchored to the wall at 16 inches center to center vertically. Then they're on the both faces. All right, and that's why you are containing the wall, containing the masonry. So that's why this is called containment reinforcement. All right. So what you see on the right side is a 2.5-story stone earth house with CR system. See, mind you, IS 13727, 728, all these codes, and they don't permit mud mortar for more than a 1.5 story. But in the mountains, in Uttarakhand, Himachal, Kashmir, and in Nepal, the houses are always 2.5 story. Okay, the flat land is not available, and they have to have space for the cattle. They have space for storage. So they have to have 2.5 story houses, and the code doesn't allow them, and that's why the system was evolved. All right. So for our own confidence, for our own understanding, shock table tests were performed. Now, we back in 2005, we installed our shock table that we had used in Kutch. This shock table we brought to Nirma University and was reinstalled there. And in 2015, after Nepal earthquake, we conducted several tests there. So this, we conducted first test on 1.5 story house and then on 2.5 story house. It's a half scale house. This is the biggest model we have ever tested. All right. And something like 14 shocks were given from, we have this 1.5 ton pendulum. With that, the shocks are given, and the structure survived very well with very little damage. All right. So, and in the 13th and the 14th shocks, the base acceleration was 2g. All right. In the upper right hand picture, you can see this pendulum has just hit the table, and you can see pretty much, that the structure is, intact. All right. So, with this data and the analysis carried out by Professor Jagdish, we prepared a package. This was done for UNDP Nepal, or United Nations Development Program Nepal, with their support. So here is, oops, wait a minute. What? Ah, why is my video not working here? Well, I think I'll show the video separately then. Okay, there you go.
Hello, sir. Sir, we are not getting audio from the clip.
Sorry?
Audio is not clear. From the clip, there is no audio. In a video clip, there is no audio. We can't listen whatever in the video, whatever we are
Oh,
performing in the. Just we can see the video, but the audio is not possible.
yeah, no, no. All right. I don't know why the audio didn't come. But anyway, this is what you see. This is a schematic. This is something that was submitted to the Nepal government. And uh, so this was approved by Nepal government in 2017. It took a long time. I don't know why. What is happening? Hello? Sorry. Yeah. And more than 300 houses have been built and several hundred artisans have been trained. So this is an excellent example of synthesis of the traditional with the modern science and material. Okay, one last issue I want to cover here is that this whole mindset that modern conveniences cannot be part of the traditional system. So here is, in the right upper pictures, you can see that is an excellent example of Uttarakhandi random rubble house where it had a cement floor and it had the standing platform like modern house. So everything that people were demanding. On the left side, you see this is our mud house in Dehradun outskirts near Masuri, and this is like this is a 1.5 foot thick mud walls, and we also made a modern kitchen in it. All right, so all the modern conveniences can be there. All right, just one other factor I want to mention here is the energy consumption in the construction, because all the materials which we use, which have the special properties, I mean, these properties have been created by the consumption of these energies. A typical brick uses 1850 kilocalories and cement uses 3750 kilocalories per kg and steel 8500 kilocalories. So typically uh, every house consumes a lot of calories, and this means it has carbon footprint. On the other hand, in the vernacular building system, it has very little embodied energy, if any, and as a result, it emits very little poison in air. So also another great thing about these traditional systems is that it allows recycling. Because recycling means very small carbon footprint and requires no long distance transportation that consumes energy and that pollutes air, and it's suitable for local climatic condition. I basically covered all these points earlier. So this is the most green and sustainable option. All right. I mean, today, with all this Western influence, we are talking about green architecture and all that, but we have these wonderful examples in our backyard. All right. So this really, if you continue using vernacular systems, they will contribute significantly towards reducing the impact of climate change and this. I mean, to me, this is the greatest disaster, the climate change, not earthquake, not cyclone. They come and go, but this thing is going to be there, and this is going to create changes which are very, very scary, and we have to be scared. All right, then only we'll do something about it. Now these kind of buildings account even today for 75% of houses and infrastructure building in small towns and rural areas. So they form a most important segment of construction activity. So, if these things are vernacular systems are continued on large scale, I think they will help us tackle the climate change and global warming. Now, here I want to just bring one interesting example of a house we built 30 years ago. All right, this is built about 30 kilometers from Ahmedabad, and it's a mud wall house. Now, number of technologies were used. Number one, we had these cladding tiles. So on this mud blocks, we attach the cladding tiles. A very simple mechanism to make the walls not only rain resistant, but also it is snake and mouse resistant. They can't burrow in the mud wall. Number two, you can see we have this timber beam with wire reinforcement. So simple trusses were made so that smaller diameter timber could be used. And ultimately, timber is also scarce material, and we need to conserve it. Here was as the precast column we had made, because this is something that goes in the ground and it rots very fastly. Acha, one more thing I want to mention here that we are very proud of. The timber you see in the roof is all tertiary timber, basically eucalyptus. Imagine 1990 we built the house and still it survives. All the timber, which typically would have deteriorated completely in 5 years, because we carried out a hot and cold treatment on site, that timber has still survived. All right. So today, I mean, timber should be used and can be used, but with preservation. And this is the most versatile material, and it should be promoted. All right. Yeah. Another thing is, because to conserve timber, we eliminate the frames, and here is what you call a frameless door. Old pivots, which were used, they're very effective. There is a system with which you can attach the pivot in the wall. So there is a pivot, frameless door and a frameless window on the right side, the vertical pivot. So all these things are possible. All right. So here is the house back in 1990, and here is a house, the same house after 30 years. All right. Now, interestingly, the PMAY's main requirement is the house should be 30 years. A house should last for 30 years. So my question is, can this house qualify for PMAY? All right. All right. Uh, all right. I think we have talked about this. The vernacular systems are very versatile. They can be modified to change the context. They can be made disaster resistant in an affordable manner. What is required is to do research and infill trials. All right, to remove the age-old irritants. I mean, today typically people don't want to use clay tile roof because they say, "Oh, the monkeys break them." All right. So what can we do about that? Why can't the IITs and NITs do research on that? The timber preservation. Why can't they be, why can't that be made mainstream? Why can't every village treat the timber? All right. A lot of simple things. So what is required is to do synthesis of the modern science and technology with the traditional systems. Okay. And to build people's confidence in that. All right. And we need to bring in respectability. And I think it's the education system that should do that. All right. So I think this is all. We need to think safe. We need to think green. We need to improve vernacular. I think that's the way to go. And hence, we need to educate our engineering students about the vernacular systems and bring respectability in their mind and hence in everybody else's mind. Thank you very much. All right. I think I've ended my presentation.
Thank you so much, sir. It was really, really informative for all of us. I would like to ask attendees if anyone has any kind of doubt, they can ask sir now, related to the session, related to the topic, anything. Yes, please. If anyone have kind of doubt, they can ask by unmuting their mic, or else they can write in the chat box. Uh, Sir, there is a question in the chat box. Mr. Bhushan sir has asked that wood construction in flood-prone areas is not done. Bricks are weak in shear, so reinforced masonry is used but costly for more than 3 stories. Tolu construction in China is good, but issues with the size in execution. Bamboo construction quality and quantity is an issue for mass housing. Japan has excellent joint connection in timber. So he is asking how to bring vernacular construction for masses.
Yeah, I mean, that's a That's a very big question. I mean, a lot of things may be happening in China and Japan. All right. I think what is required is to do what is feasible here. What is it that artisans can do? And I mean, again, when you say mass housing in urban and mass housing in rural are entirely two different games. All right. So mass housing in rural, you have to empower rural people build their own houses. No one else has to build for them. Okay. So while we are talking about vernacular systems, I'll say essentially that as far as the rural areas are concerned, what is required is to improve their technologies, to make sure that the materials they're able to access, so that decentralized treatment preservation plants are made, simple plants. And in Bihar, if they could have that bicycle mounted bamboo preservation system, these are very, very viable systems. So we really need to things which are viable, which are replicable. All right. Urban thing is a completely different thing. The context is different, where you have this high intensity population, and where you may have to, you will definitely have to go about 3 story. And so the context is very, very different, and technologies will be different. And today, today there is a lot of talk about emerging technologies. But although I'm not involved in that, I know some people who are, and there are serious reservations that many of them have mentioned, because especially the kind of investments that a lot of these emerging technologies require are huge. And as a result, bringing in these technologies and put them in the mainstream and all that, may require a long gestation period and lot of investments. So those things look great when they're demonstrated, but I think to bring in for masses and on large scale, I think the hurdles are immense.
Hopefully, the doubt is being
You are
cleared.
you are
Sir,
allowed to
there is
unmute your mic yourself. So you can ask by unmuting your mic.
Sir, good morning, sir.
Good morning.
Sir, as this today's session was really so wonderful, and things which has been discussed here, I have already seen this in Arunachal, and I am from this hilly area of Uttarakhand. We have this 2.5 story house with the traditionally built constructions, and also I have been there in the ahead of Leh. So I have seen such type of works and also executed that bamboo thatch houses. But sir, main reason of that bamboo, this split bamboo houses, that security, that privacy and security is there, sir. Again, sir, may I know what is the phenomena of these 2.5 story buildings which we have, but we are not aware of what is the logic behind what our ancestor had, the reason behind this construction 2.5 stories building, sir. Thank you, sir.
No, I mean, I think your question is not very clear, but I mean, as far as in the hills,
Yes.
when I'm talking about 2.5 story, typically it's, I've seen in Uttarakhand where the ground story is used for cattle, and part
Yes.
of it will be kitchen. Upper story is your living quarter, and then you have the upper half story, which a lot of times people use to store things. Okay,
Right.
main issue here is that I mean the flat land is not there, and the only way people can have adequate space is by building 2.5 stories or 3 stories if they can. There are
Right.
places where they, like this Koti Banal architecture I've seen. It's a 6 story structure, but that kind of thing is not replicable. But I personally feel that, like, say, even this containment reinforcement system that we have worked on and that Professor Jagdish has designed, the results are very encouraging, and further research can be done to make it maybe even 3.5 story. All right. So
Right.
ultimately, see, to me, any technology, I mean, our experience, we started with this uh, containment reinforcement system in Uttarakhand back in 2014 after the Kedarnath tragedy. And it gave us a lot of confidence because the Masons learned that technology very fast. And then we took it to Nepal. And what we find is that even if the house is, I mean, one day march from the road, carrying in that wire bundles and carrying in the straps of weld mesh and all that is lot easier. I'm not saying it's easy, but it's lot easier than carrying in reinforcement and cement and sand and aggregates and all that. So logistically, it made things very easy. And back in 2014, after Kedarnath tragedy in Uttarakhand, there was this World Bank funded rehabilitation program where 3,500 houses were built. Now I was there as a consultant, and what we found out, because the government wanted that even if somebody uses random rubble masonry, cement mortar must be used. All right, this is our engineers mindset, and they insisted that it should have RCC bands. All right. So as a result, what problem they had was that in the remote houses, carrying in aggregates and sand. I mean, getting that from the river valley and all that was prohibitively expensive and time consuming. So this is where containment reinforcement is one example. That is not the only example. And this is where research is required so that simpler technologies are brought to people and they're easy to adopt. And what we find is that, I mean, the first house we built in 2016, and the mason so quickly picked up and he created his own jugaad to do it faster. All right. So what I'll ultimately say is that in the hills, if people can build 3.5 story houses, then that would be even better, because, and I'll tell you, after Chamoli earthquake, because when the houses are not well made, typically the upper story suffers more damage because of greater shaking. And what happened in Chamoli earthquake was that large number of houses, the upper story was cracked, and as a result, a lot of people dismantled that upper story. Now, so several years later, I'm sure probably they went back and built the upper story because they had no land to live in. Okay. So, I mean, I hope I've answered your question.
Thank you, sir.
All right.
Thank you.
So there are also a few questions in chat box. Mr. Mohit Kumar has asked, what has to be the composition of mud mortar?
Okay. See, I mean, mud mortar typically should not be extremely clay. Okay. I mean, it should not have more than about 15% of clay. Okay. Because so in areas which are predominantly clay soil, they end up adding, granular soil like sand, because highly clay soil will crack and they will shrink. So ideally, your mortar would be what I would call a clay sand and not a sandy clay. And typically in every area, people know which is good soil for mortar. All right. So a lot of times we feel that when we go out as so-called experts and we try to teach them, we find we have to be very careful. So we leave it to them. I mean, what we do in our intervention is that if they're making some major mistakes, then we try to intervene. All right, because like when we are working with random rubble, we know that they're breaking major rules of how to place a stone and how to fill the voids and things like that. So when it comes to mud mortar, mud plaster, local people know which are the local sources of soil, which are most suitable for that particular application.
Thank you, sir. Sir, there
Sure.
is another question. Professor Radadia has asked to please tell about strain testing for vernacular structure or adopt break.
What testing?
He has asked to tell about strain, strain testing, vernacular structure or adopt break.
All right. See, this is, I mean, uh, one does string testing and thing like that when you're really getting into hardcore research. All right. Because the testing we have done, has been done in the field. And typically, the field testing you do to observe the most common type of damages. Right.
तो
So
आप
in
मुझे
case of seismic condition,
feeling
when you have out of plane forces or when you have in plane forces, what is the kind of damage you have, and based on that, the testing is done. So all
three
the testing we have done, we have used accelerometers to
three
find out what kind of acceleration is getting generated.
आंसर शीट
But
बताओ
this kind of testing, we don't get into the strain testing.
और
Those are
बताओ ये स्क्रीन
typically maybe on the masonry pedestals. So that's very much academic, and we have been working very much on the practical side in the field.
Thank you, sir. So there is another question by Professor Poonam Modi, ma'am. She is asking, what is your vision about the vernacular structures in Gujarat 5 years down the line?
What is the last word?
What is your vision about the vernacular structures in Gujarat 5 years down the line?
In the years down the line.
Yes, 5 years.
See, I I personally feel that there should be number one masonry structures. I think there should be as little of cement and steel as possible. We all know that the cement and steel means dilution. So see, when it comes to government structures, if it's panchayat house, school, they are of higher specification. But even there, I'll say that masonry structures should be promoted because they set examples for the people to follow. Now, obviously, school or panchayat building and these are what we call the infrastructure buildings. They will have a higher specification, but when it comes to houses, people can use lower specification, but even there, people should know what they need to do. See, today, what we are finding, we have been involved in building artisan training for last 25 years, and we have an ongoing program for last 15 years, and we have trained so far something like about 15,000 masons and bar benders and so on and so forth. The problem arises in the rural areas that number one, they don't know the rules. Number two, even if they know the rules, people don't allow them to do that. Mind you, see, people, house owners also have their own ideas about what is right, what is wrong, and of course they are not informed well. So when we have technologies which are simple, it's easier to educate people about them, and so my feeling is that in terms of vernacular, vernacular is something that is constantly changing. All right, it's not something fixed. I mean, there was something that 200 years ago, maybe 100 years ago, things changed a little bit. 50 years ago, they changed a little bit more. Now they've changed. What I feel is that, because since we all are instrumental, you and I and all of us are instrumental in bringing those changes. Our vision should be that whatever happens, it should be people friendly, and it should be something that people are able to manage, people are able to afford. When I say manage, people are able to maintain them. So all these issues have to be there, and I personally feel that there should be as little use of cement and steel as possible. I'm not saying that don't use them, but use them little. So bands, yes, they should be there. All right. But for roofs, I still feel that at least the top roof would be best be Mangalore tile roof because it's so easy to make it waterproof. Now, against monkeys, well, this is where I think our research departments have to do something about this so they don't get damaged. They are able to withstand the impact, So and really in arid areas, I think the mud roofs, I mean mud houses should be promoted. They should be made respectable. And I think there has to be something. I mean, the carbon footprint should be connected to the houses. All right. Because if we don't, then we are facing problems.
Hopefully, everyone's doubts have been cleared. Do anyone have any more doubts? They can ask by unmuting their mic. Okay. Uh, I guess all doubts are cleared. Thank you, sir. Thank you for sparing your valuable time with to us, and thank you for sharing this immense knowledge of yours and this vast experience with all of us. Thank you so much. It really means a lot for all of us. Thank you, sir. All the participants are yes, sir.
No, it's been my pleasure.